we looked at the inverse of a matrix last lesson. This idea of if you have some matrix, A, right, we define its inverse, A with a -1 there. It's not A to the power of -1, but that's how it's written, okay? Such that if you multiply these two together, what should you get at the other end? You should get the identity matrix, right? So, if it was, these things were going to give you a 2 by 2 over here, okay? That would be I2. That would be this identity matrix that's 2 rows, 2 columns, okay? So this was our definition, okay? Now we did it with a set of numbers. I can't remember actually. Can we see what were the like there was a 4, 5, -1, 3. Who's got
4?
Yeah, going across.
Yeah.
3, 4. Yep.
-5.
-5, 1.
Yeah.
Okay, good. So we had this, and then we determined its inverse, right? And it had some fractions and stuff in it. What did we get? Did anyone have it written
no,
there?
we didn't do that one. You gave us an easier one.
Oh, I did. It was like 1, 2
Yeah, it was
something,
like
wasn't it?
1, 2, 4.
Hold on.
1240.
1, 2, 4, 0. Okay.
1, 2, 4, 0.
Yeah, I deliberately wanted to make it easy. 1, 2, 4, 0. And what was its inverse?
0, 1/4,
Yep.
and then a half, and then negative an inch.
Okay. Great. So we went through the process of putting this, right, the original matrix A, and we put it together with the identity matrix, like so. Okay. We rearranged it, and then out came that. And actually we did go ahead. We tested it, and when you do that, you just get the identity matrix as we expected. Okay. Now where I left you was to say, okay, this is one thing to do maths with numbers, right? That's fine. Okay. But the real test of whether you can understand something and manipulate it is if you can take it from just a particular case to a general case. Like, what if I had any matrix A? Can I work out its inverse? And there are sort of clues that we should be able to. Like, look at these numbers here. Okay, just for starters. Look at a half and a quarter. They're sort of in opposite corners of a 2 and a 4. It's kind of suspicious, isn't it? Right? It looks like there must be relationships here if only we can work out what they are. Alright? So I said, if I gave you an arbitrary matrix, like say, let's define A as, what did I write? What did I do? A, B, C, D. Okay? My question was, can you work out what A inverse is? Okay? So today, I'm going to show you how I did it, and it takes a few lines, but there's a lot of symmetry to it, so you'll see the way it works. Okay? So let me get the concrete one off the board. Okay, so I've got A, B, C, D. Okay, so if that's A, right, I need to determine what A inverse is, and I'm going to be searching for 4 numbers, okay? Because as you saw, if I start with this and I put it next to its identity matrix, then clearly its inverse will also be 2 by 2. Okay, so I've got the same dimensions here. Okay? Now I don't know what these numbers are. There's something else. So I'm going to call them P, Q, R, S. And I don't know what these numbers are. That's what I'm trying to determine. Now just watch out before I go any further. What I've got here, right, these 4 numbers plus these 4 numbers, it seems like I've got 8 variables, right? But I don't really have 8 variables. Like these 4 up here, they're actual numbers, like 1, 2, what did I give you? 4 and 0, or something like that, okay? So these numbers, even though I'm writing them as algebra, these numbers are known. These numbers are unknown, okay? So I'm solving for P, Q, R, and S, and everything will be in terms of A, B, C, and D. Does that make sense? Okay, so here's the way I'm going to approach it. My first approach might be to do what we did over here, right? And have an A, B, C, D, like so. Right? And then you try and rearrange it, multiply, divide, do whatever you like, so that you can get the identity matrix over here and get something else, the inverse, over here. Okay, did anyone try that? Anyone try it? And you got there? You got there? Okay, now, I'm going to ask you to show us afterwards how much work your approach took versus this one, and we'll see which one came out on top. I'm only showing you this way because I think it's a little easier to understand, and I think the algebra will be a bit simpler, but I don't know if it's faster, so we'll find out. Here's what I'm going to do. I'm going to take this definition here, right? If I multiply these two together, I should get the identity matrix, right? So that's telling me this. Therefore, by definition, A, B, C, D, cross multiply, P, Q, Q, R, S, should give me this. Okay. Now I want you to recall, how does cross multiplication actually work? What's the process by which these numbers go together to get these? Good, good, you remember. Okay, we go across the row, down the column, okay? And we would do that each time. We'd do it 4 times, and each of these is what we call a dot product. Do you remember that? Okay. Now, in going from this side to this side, these 4 dot products represent 4 equations, right? 4 equations, 4 unknowns, okay? I'm just going to do 2, and then you'll see how the other 2 come out just by symmetry, okay? So for instance, let's have a look at this, this first dot product, which should be 1, okay? I go across the row, that gives me A, and then P, okay? A and then P, plus, what's next? B times R, across the row, down the column, okay? That's the first dot product, that should be 1, yeah? Keep going, across the row, but down the next column, right? I should get, let's see here, so A, Q, right, next column over, plus B, S, right? What's that going to be equal to?
0.
This next term across, that's 0, right? I have 2 equations. This is good. I will go down to the next row to get the other 2 equations, right? So I'm going to go across this row now, C, P, D, R, right? That should give me 0 as well. And then my last dot product, this guy over here, CQ plus DS. That's going to give me 1. Okay, so have a look at this, right? I could name these 1, 2, 3, 4. But you can be a little more clever about it, right? Think about it. I've got 4 variables to find, but do you see they're kind of in pairs because of the way that I did the dot products, right? Look at these 2 here. Do you see these 2? Right? Remember, A, B, C, and D. I know what those numbers are. I'm not trying to find what they are, okay? But these 2 equations here give me P and R, right? So I'm going to call this one equation 1 and this one equation 2, right? That's just 2 equations with 2 variables. Does that make sense? Yeah. Accordingly, I'll call these 3 and 4, but you will see what I do with 1 and 2 will be exactly the same as what I do with 3 and 4 because it's literally the same thing with different letters. Okay? So now focusing on these 2. This equation 1. There's equation 2. We started, this is very appropriate, we started looking at matrices by thinking about simultaneous equations. So if I showed you these 2, what would be your first strategy for how to solve these? You got 2. What are the 2 strategies for simultaneous equations? Either elimination or substitution. Which do you think is a better option? I lean towards substitution. You remember, either of them will be fine, but just some are a bit easier than others. Now, to do the substitution, you can go with either equation 1 or equation 2. But I think the equation 2 might be a little bit simpler because you can see there's a 0 on the right-hand side there. So when I rearrange this thing, you're going to end up with something that doesn't have that 1 flying around. Okay? So, for instance, what I could do here is I could say off of equation 1, right? If I move that dr over to the other side, I'll get Cp equals minus dr, right? So all I need to do here is divide through by C, and now I have P by itself, right? So I'm going to take that, which is from equation 2, and I'm going to pop it into equation 1, right? So if I do sub into equation 1, right? Here I'll write A outside of minus D on C R plus BR equals 1. So you can see we've achieved the substitution here, which eliminated out the P, it's got rid of it. So this is just a single equation in a single variable, I can solve it, okay? Just got to be careful with my algebra here, so I'll multiply through by C, which gives you minus ADR plus BCR equals C. Okay, so far so good. And now over here I have a common factor of R out here, right? And I've got minus AD plus BC all over C. Okay, so I only need one more step. Now, for reasons that will become clear by the end of the construction of the inverse, I'm going to take out this minus sign here, and I'm going to put it on the top, on the numerator, which leaves me with AD minus BC on the denominator, okay? So this is great. I've found one term in my inverse matrix, and now it's just kind of a process of working out the rest of the algebra to find the other terms. The first term I can find is P because it's matched up to R, right? So if I substitute into here, let's call this equation to A, right? If I sub into to A, okay, P is going to be equal to minus D over C times this, right? So that's minus C on AD minus BC. The C's are going to cancel, the negatives are going to cancel, and I'm left with this, okay? So now I've got P, I've got R, and if you go through exactly the same process of substitution and simplifying things out, you will get Q and S as well. This is going to be your result. You're going to get the inverse be equal to, okay, this is P, right? We just worked that one out. R is down here, minus C. And if you follow through with the algebra, what you'll find is you'll get minus B over here and A over there. Okay? And what's great about this is you can quickly check how it works with the previous example that we did, right? I think what we had was 1, 2, 4, 0. That was A. Okay? So A inverse is going to be, well, you can see AD minus BC, which I'll come back to in a second. That comes up again and again and again. So I'll just work that out for starters. AD is 0, minus BC is negative 8. So everything is going to be divided by negative 8 because it comes up on the denominator over and over again. Okay, so this will be divided by negative 8, divided by negative 8, divided by negative 8, divided by negative 8. And now all that's left is to put in A minus B minus C and D, right? A minus B minus C and D, okay? Which if I simplify that, sorry, this is a bit messy, 0 divided by whatever, this is going to be a half, this is going to be a quarter, and that's negative an eighth, which is exactly what we were expecting, okay? So that's it. It was harder, but it's totally doable. And before we finish here, I just want to point out to you that this denominator, right, it comes up repeatedly, so clearly it's important, right? It's so important it gets its own name and its own bit of notation, okay? So AD minus BC, we call it, for matrix A, we call it the determinant. Determinant. It feels a little bit like the discriminant in quadratic equations, right? It determines something. We'll wait until next term to actually work out what it does determine, but we'll get to it later. The notation that we use for this is an A with big, well, A is the name of the matrix, right? And then these big bars on either side. That's equal to AD minus BC. That's the determinant. So I can rewrite this in a much more concise way. I can write this as D on the determinant minus C on the determinant minus B on the determinant and A on the determinant. And that's the inverse.